Okay. So good morning, everyone. This morning, we're going to have the laboratory exercise 6, in which we're going to use two of the algorithms of supervised machine learning with the Naïve base and logistic regression. I have already posted what do you call this? The lab exercise there. I would just like to uh, give a brief discussion or perhaps a lecture about this notebook here. So this notebook contains dataset preparation, naive-based classifier, logistic, text classification, and you're going to do the comparison and the reflection. So for the task number 1, but before that, you are required to do it or download muna the Word file, no? So the dataset that we're going to load here is the iris and the breast cancer. So what will be happening here is that based on our previous lecture, we're going to use uh two different algorithms, no, as mentioned earlier, the naive Bayes and logistic regression. Before we have used the KNN tree and decision tree. So we're going to know which among these are more or have more accuracy, precision, recall, or has a more has a higher model evaluation metric. So for naive-based classification, just copy and paste whatever is there. No? So for task 1, you're required to prepare the data set. For task 2 naman, you're going to use the classifier naive base. No? So how do we do that? We need to import the Gaussian NB, and then we call the function. All right, and then we print the results, no, the accuracy and the confusion matrix as well, for us to know the precision recall F1 score. So what you see is the precision of the true positives and the false negatives, the recall, the F1 score, and the support here just pretty much says that 42 data sets of malignant were used and 72 for benign for testing. So the accuracy is like 93.86 or approximately equal to 94%. Using supervised machine learning as well, we're going to use the logistic regression classifier. So I have already mentioned in the lecture about the logistic regression classifier that it predicts only two classifications. So in this case, we can use the logistic regression because we are only to classify whether or not that patient has a benign or malignant case. So if you can see that the logistic regression gave a higher accuracy of 98%, no? So how do we do that? We need to import the logistic regression from the sklearn model, okay? And then we just write everything what's here, no? So just and then we're going to inspect the feature coefficients afterwards. And then what are the top 10 features by coefficient influence afterwards? So what does it mean? What does it mean? What does it show rather are the coefficient influences of the features. So the mean, compactness error, the fractal dimension error, symmetry error, and so on and so forth. Now, for task 4, since We want also to practice the data sets that are not just the iris, no, and the breast cancer. We would also want to use the text classification for the naive Bayes and logistic regression. So in this case, we would want to import that the 20 news groups no under the sklearn datasets. Again, ang collab, meron yan siyang mga datasets that are already present in the library, no? So we're going to fetch the 20 news groups and then use feature extraction. Then we are going to use the vectorizer here. So vectorizer, um, if you let's uh, so the vectorizer is or refers to a tool or technique, no? So it's mentioned from the word vectorizer. It used to convert raw data or text into numerical vector representations. No, so it's like converting what it's like converting it to a vector so that the representations under the machine learning could better be understood and can be processed. So vectorization yan siya. So, for example, kanan siya, this creates a bag of words representations, counting the occurrences of each word or n-gram in a document. So later on, we would understand what this means, no? But yeah, we are going to load the subset of 20 news groups. So what is the news group? So unsa din ni ato ang import dinhiya. So we imported this ani siya. They are decentralized global discussion forums that function like internet bulletin boards. So, kani siya na discussion group includes size space, madami pa yun siya, no? According to Kaggle, ayan siya, mga graphics, mga sports. So, may mga pinag-uusapan sila doon sa news group. It's like a news thread, no? Which was very popular before uh, Facebook existed. Okay, so we would want to have a test size of 0.2. Okay, and then we're going to import the multinomial NB from the naive base or naive base, and we want to know how accurate is our model that we are going to create, and that shows that it's 99%. For logistic regression, that's also 99.50 or that's 99.6%. So our objectives for the NB or the what do you call this? Task 4 no in text classification is that uh ito